Hello everyone, for this lecture video, I'll be discussing the second installment on the topic stoichiometry. The following are the objectives. We need to calculate percent composition of chemical compounds correctly, and then second is to determine empirical and molecular formula of compounds from given percent composition. Okay, now how about the outline? This will be the topic outline. We have the percent composition first. Second is the empirical formula. Third is the molecular formula. Again, apologies for the ambient noises that you may be hearing or is currently hearing or will be hearing along the way. But nonetheless, let me continue by discussing this lecture. Percent composition. The percent composition by mass of a compound is the percent by mass of each element in a compound. Let me repeat. Percent composition is simply by mass of a compound is simply the percentage by mass of each element in a compound, characterized by the formula percent composition, okay, percent composition of element at hand, or the element of that you wish to compute of. You have here n multiplied by number of atoms, okay, number of atoms, and then multiplied by the molar mass of that element, all over the mass of the compound. And do not forget, there must be multiplied by 100 since we're talking about here percentage. So let me repeat, percent composition of an element is simply n, this represents the number of atoms, times molar mass of element, all over mass of compound. So we can simply rewrite this further into n multiplied by molar mass of element all over molar mass of compound times 100. Okay, so n represents the number of atoms. So yun po yung mga subscript ng mga elements sa compound. I-multiply po natin sila with their respective molar masses and then divide them by the total molar mass of the compound times 100, therefore getting the percent composition of that particular element. Okay, so that is percent composition. All right, to better understand percent composition, let us have a sample computation. So let me read the problem. Determine the percent composition of each element in the compound glucose. C6H12O6. So let me write that one. That is C6H12O6. So dahil po ang tinanong ay percent composition ng kada element, ibig sabihin, tatlong beses po natin uulitin ang pagko-compute ng percent composition of X. X represents any element, okay, from the compound. All right, let's start. The first thing that we need to do is to compute for the molar mass of C6H12O6. Since tatlong beses natin siya gagamitin as a denominator, okay, to make things simpler. So let me again compute for the molar mass. That is simply accounting first the number of atomic masses or molar masses for each particular element. So let's start with carbon. So I'll be getting the atomic mass for carbon. I'll be rounding it off up until 2 decimal places. So I'll be getting 12.01. For hydrogen, this one, I'll be getting 1.01. And then for oxygen, I'll be rounding it off up until 2 decimal places as well. That is 16.00. 16.00. And the next step, I need to multiply each respective elements with their subscript or number of atoms. That is 6 for carbon, 12 for hydrogen, and then 6 for oxygen. Then afterward, I need to multiply each particular expression with their with the factors so that I can have their product. So 12.01 times 6, that will be 72.06. Then I have next one is 1.01 times 12. I'll be getting 12.12. And then for 16.00 times 6 for oxygen, I have 96.00 because I follow the least, okay, significant figure multiplying them. So supposedly 12 12.12. This should be, I'll be getting this one as 12.1. Okay, so adding them up, right? So I'll be getting 72.06 plus 12.1 plus 96.00. I have 180.16. Okay, or rounding it off up until least decimal places, so I'll be getting 180.2 grams per mole for the molar mass of C6H12O6. Okay, now at this point, I already have 180.2 as my denominator for each composition. So let me start with carbon. Percent carbon is equal to number of atoms. Number of atoms of carbon is 6 multiplied with the atomic mass or molar mass of the element. Molar mass of the element for carbon is 12.01 grams per mole all over the molar mass of the total compound. This is 180.2 grams per mole. Grams per mole will be cancelled, multiplied by 100. Okay, I'll be having this particular answer. So that is 6 times 12.01 all over 180.2 and then times 100. Okay, so I'll be getting the particular answer as 39.99%. So let this be a consensus. Okay, now when we answer percent composition, let's round off our answer up until 2 decimal places. So this this may just be a consensus in this context. Okay, so 39.99. All right, how about the next component? Now the next component will be percent composition of hydrogen. So again, same procedure. I'll be writing the numerators as a subscript for hydrogen, which is 12 multiplied by its molar mass, which is this one, 1.01 grams per mole, all over 180.2 as well, 180.2 grams per mole. Now that particular unit will be cancelled, grams per mole will be cancelled, times 100. So multiplying this particular bit in your calculator, you have 12 multiplied by 1.01 all over 180.2 and then times 100. I have this answer. So again, as a consensus in the context of percent composition, let our answer be up until 2 decimal places. So I'll be writing 6.73 percentage. Okay, now last but not the least, let me continue with percent oxygen. Percent oxygen, same procedure, multiplying it with its subscript N. My subscript is 6. So 6 times molar mass of the element, 16. So 16.00 grams per mole, all over 180.2 as well, grams per mole, times 100, cancel gram per mole, and then input this particular bit as well in the calculator. I have 6 times 16.00 all over 180.2 times 100. We have 53.27 percentage. Again, rounding it off up until 2 decimal places in the context of percent composition. All right, so at this point, let us just check if we have the same answer with that of the PowerPoint. So I actually have the same solution with the PowerPoint and then with the answer, 39.99% for your carbon. And then we have here 6.73% for your hydrogen. And then for oxygen, I also have 53.27% for oxygen. Okay, so I hope this is clear on how we do or calculate percent composition of each element for a particular compound. Now at this point, let me continue the lecture. Let's talk about empirical formula. As discussed before, empirical formula shows us the simplest whole number ratio of the atoms present in a compound. The empirical formula of a compound can be determined using the percent composition, meaning to say whatever you learned from the previous bits, which is how to compute for the percent composition, those things will be applied in this particular topic. Now let me explain the procedure. Now this will be the procedure on how we do on determining the empirical formula. First is that we need to identify the percent by mass. Now, there will be times that the percent composition are not provided. Okay, so we need to compute for the percent composition beforehand. However, if the percent composition is already provided, that's a good thing. We may now proceed with the second step, which is converting all number of, or rather converting the elements or the unit element into number of moles, or simply computing for the number of moles of the element. And then we need to have the mole ratios of each element. And last but not the least, we now have the empirical formula. Now, what will be the specific or how is this being done? Okay, for the percent by mass, you simply, if the percent composition is provided, we directly convert percentage to grams, okay? And then convert grams to moles by dividing with molar mass. So first is that if the percent composition were already provided, convert percentage directly to grams. And then the second step is convert unit gram into unit mole by means of using molar mass. So we just simply apply the skill sets that we've been learning from the lecture videos. Second bit is that we need to divide all mole values by the smallest mole value. That means after doing step number 2, we now have the unit moles for each element. We divide all mole unit by the least value of the mole unit, the smallest mole value. And then change to integer subscript. So whatever the quotient from number 3, that will be the subscript of your empirical formula. Okay? So, pakita ko na lang. Let me give an example. So, sample problem. What is the empirical formula of a compound containing 70.19% lead, 8.14% carbon, and 21.67% oxygen? So, let us follow the steps. So, step number 1, convert percentage to grams, assuming the sample is 100 grams. So, if percentage or ang binigay po ay percent composition, we proceed with step number 1. So dahil percentage yung mga yan, i-assume po natin na yung buong sample ng compound ay 100 gramo. So we assume the sample is 100 grams. The percentage can be directly converted into grams. So that simply means that your 70.19% is now 70.19% grams of lead. And then your 8.14% carbon is now 8.14 grams of carbon. And then your 21.67% oxygen is directly converted into 21.67 grams of oxygen, because we assume that the sample is 100 grams. And then step number 2, convert grams to moles by dividing with molar mass. So we simply need to convert unit gram into mole unit for all. So we'll be doing this particular bit 3 times. So let me start with lead. 70.19 grams of lead. Convert it into gram to mole using molar mass. So I'll be looking at the molar mass of lead from the periodic table here. So lead is found here. So lead 207.2. So I'll be getting 207.2. So 207.2 grams and then 1 mole here. So dividing, or rather canceling grams, I have now the unit mole. The next one, let me write first the solution, 8.14 grams of carbon. Again, using the molar mass of the carbon as well. Carbon is this one. I'll be getting 12.01 grams, 1 mole. Grams will be cancelled. I now have the unit mole, which is the one I'm required to have. The next 21.67 grams of oxygen multiplied by the molar mass as well, 15.999. I'll be getting up until the rounded off figure, which is 16.00 grams, and then 1 mole. Again, I'm just applying dimensional analysis in this particular bit. And now I have the unit mole, which I need for all particular elements, which is your step number 2. And then input them in the calculator. Okay, so I have the same solution with this one. So I'll be getting this particular answers. Okay, so for lead, I only have a 4 significant figure from the given. So I write 0.33888. And then for carbon, carbon's given is 8.14, 3 sig fig, 0.678. And then for oxygen has 4 significant figure, I'll be writing 1.354 moles. Okay? Okay. Next step. Divide all mole values by the smallest mole value. So that simply means in Tagalog po, i-divide po ang kada sagot, itong mga mole PB, mole C, and then mole O sa pinakamababang value. So ang pinakamababa po sa tatlo ay itong lead. So i-divide po natin sila lahat by 0.3388 po. So 0.3388 mole, and also this one 0.3388 mole. So mole will be cancelled. Right, so this will be the answer. So we need to round them off into a whole number. So 0.33888 divided by itself is 1. 6.678 divided by the 0.3388 is approximately 2. And then for oxygen, I have 4. Now, 1, 2, and 4 will be the subscript for the respective element. So therefore, our final answer would be PB1. The subscript is 1. Automatically, that is 1. Do not write anything about in the subscript. Carbon 2. So I'll be writing 2. Oxygen 4, because 4 is the answer. So this will be your final answer for the empirical formula of this particular given. Okay? So I hope this particular sample problem gives you an idea on how we can compute empirical formula. Alright, before we proceed to the next topic, there are some things that we need to take note of for empirical formula. If the molar ratios have decimals such as 0.33 or 0.25 or 0.5, okay, do not immediately round it off. So for example, if it's exactly 0.33, 0.25, or 0.5 as the decimal numbers, do not immediately round it off. For example, the mole ratios for the following figure or the following expression that you had was, say for example, 1.5, and then say for example 2.33. Okay, and then you have here, let's say 2.1. Okay, so looking at this one, you can see that 1.5 has 0.5, 2.33 has 0.33. So according to the rule, kung meron daw po silang decimal point or decimal numbers na eksakto po, eksaktong 0.5, 0.33, or 0.25, wala mo na mag-round off. Ang gagawin mo daw muna ay, instead, multiply all the mole ratios by the lowest whole number. Okay? So sa tatlong ito, itong 2.1, pwede na natin siyang i-round off. So pag ni-round off ito, we have 2. So between the 3, alin na pinakamababa? I mean, itong dalawa, hindi natin pwedeng i-round off muna. So alin ang matitira? Itong isa lang, itong number 2. Let me repeat. Itong dalawa, itong sa 0.5 and 0.33 na mayroong decimal point as the value, hindi mo pwedeng i-round off. Instead, kailangan nating i-multiply lahat ng mole ratios by the lowest whole number to make them a whole number subscript. At dahil hindi pwede si una at pangalawa, itong pangatlo pwede na, 2.1. So pag ni-round off, magiging 2. So siya na lang ang pwede na gamitin. So i-multiply natin itong dalawa by 2. Okay? So at this point, you will have 1.5 times 2. Okay, so looking at that one in your calculator, 2, sorry about that, that's 2 times 1.5. I have now 3. And then you have here 2.33 times 2. You have 4.66. And then at this point, pwede na daw natin siyang gawing a whole number. So 3 will remain as 3, 4.66 will be 5, and then 2 as 2. Now this will be the subscript for your particular elements. Okay? Alright, at this point, we'll be talking about the last installment or the last topic for this particular lecture, which is all about molecular formula. Now, the molecular formula shows the exact number of atoms of each element in a molecule. It represents the actual formula of a molecule. The empirical formula may or may not be the same as the molecular formula. Meaning to say po, may times na kung ano na yung empirical formula mo, yun na rin mismo ang molecular formula. So let me repeat, the empirical formula may or may not be the same as the molecular formula. Okay? Okay. Let me show you the procedure on how we can determine the molecular formula. First is determine the empirical formula of the compound, meaning to say whatever you learned in determining empirical formula, that will be applied in this particular lecture. So, ibig sabihin, may times na bago mo pa malaman ang molecular formula, dapat magawa mo muna ang pag-compute ng empirical formula. Next, calculate the empirical formula mass. So, pag nakuha mo na yung formula sa unang step, aalamin mo lang yung molar mass ng empirical formula. And next, compute for the value of N. N is equal to molecular formula mass all over empirical formula mass. Now, the numerator is most of the time provided or given. You just need to compute for the denominator. And then derive the molecular formula using this particular format. Empirical formula, the formula that you've gathered from the first step, multiply the subscript of the empirical formula with N. N is this one, okay, the third step, and that will be your molecular formula. All right, let me give an example. Caffeine found in coffee and tea contains 49.5% carbon, 5.20% hydrogen, 28.8% nitrogen, and 16.5% oxygen by mass. Its approximate molecular mass is 194.1 gram per mole. Find the molecular formula of caffeine. So step 1, determine the empirical formula of the compound. So that simply means gawin po lahat ng procedure on how we compute for empirical formula. So let me start with this one. So since percent composition na po ang provided, I just simply need to convert percentage into grams directly. So I'll be writing 49.5 grams carbon instead, 5.20 grams of hydrogen, and then 28.8 grams of nitrogen, and then 16.5 grams of oxygen. So the idea behind this one is that since percent composition na po siya, we assume that the totality of the compound is 100 grams. So that is why we can directly translate 49.5%, so on and so forth, into grams. So what we'll do here is convert gram into unit mole by means of molar mass for each element. So let me start with carbon. So looking at the, the molar mass of carbon here, that is 12.01. Again, 2 decimal places rounded off. Grams will be cancelled. I now have the unit mole. The next one is your hydrogen. Hydrogen is this bit, 1.01, 1.01 grams, and then 1 mole. Grams will be cancelled. I now have the unit moles of hydrogen for hydrogen. And then nitrogen, next one. Nitrogen is 14.01, 14.01 grams, and then 1 mole. Cancelling the unit grams, I now have the unit moles of nitrogen. Last but not the least is your oxygen. Oxygen is this one. I'll be getting the molar mass according to 2 decimal places rounded off. So that is 16.00. So 16.00 grams, 1 mole. Grams will be cancelled. I now have the unit moles of oxygen. And then input that all of this in the calculator. So I actually have the same solution with that of the PowerPoint. So let me write that one. So this will be 4.12, 5.10 if we input this one in the calculator, and then 1.03. Again, it follows significant figure from the given values here. Okay? Okay. Next step is divide the mole units according to the lowest value. The lowest value is 1.03. So we divide all of them by 1.03. Okay, so divide this one by 1.03 mole. This one is 1.03 mole as well. 1.03 mole, and then 1.03 mole. Looking at the PowerPoint presentation, when we divide the particular units, so mole will be cancelled. We now have the mole, the mole fractions for each. So for carbon, we have 4. Hydrogen, we have 5. This one. For nitrogen, we have 2. For oxygen, we have 1. Now, this will be the subscript for your empirical formula. So therefore, for this particular empirical formula, we have C4H5N2O. Okay? That's the empirical formula. We have done or we've been through step number 1. Next step. Step number 2 is calculate for the empirical formula mass. So that means the molar mass of C4H5N2O. So first step is account each element and also their molar masses. So we just look at our previous given here. For carbon, we have this one, 12.01. Hydrogen is 1.01, this one. Nitrogen is 14.01. Oxygen is 16.00. And then multiply them respectively with their subscript. That is 4, 5, 2, and 1. Okay? Then after which, we just add the particular products, the summation of the products, we have this answer. So the total products, okay, so we need to have the summation for all of this. We will be having 97.11 grams. Okay, that is the empirical formula mass, not just grams. Okay, this will be a total of 97.11 grams. Okay, next is compute for the value of n. The value of n, the formula is, as we all know, is shown here. Okay, sorry about that one. This should be gram per mole. So this should be gram per mole. Sorry about the typographical error. So n, we are now in step number 3. Molar mass of molecular formula. Do not worry, the numerator is already provided by the problem, divided by the molar mass of your empirical formula. What is the denominator? This one, 97.11. So 97.11 grams per mole. And your numerator is already provided from the word problem, 194.1 gram per mole. Dividing them, we have a rounded of whole number, which is 2. N is equal to 2. Last step, write the molecular formula. So using the format, okay, so C4H5N2O, this is our empirical formula. Multiply the subscript by N, which is 2. We now have, this will be C8H10N4O2. So just distribute 2 into the subscript. We have this final answer as the molecular formula. Okay? Okay. So I hope you understood the process on how we can compute the molecular formula. Not just the molecular formula, but also percent composition and empirical formula. Okay? Okay. Thank you for tuning in, and I hope you learned a thing or two on this particular topic. Have a great day.